Hi, I'm Nick Smeltzer, Director of IT Services at Warrington Collegiate. Warrington Collegiate is one of the largest learning providers in Cheshire and Warrington. We have a number of FE courses and a number of HE courses, as well as a number of business courses. I've worked at the Collegiate for around 10 years. My background was originally environmental science back in the late 80s. I did my first degree in environmental science at the University of Hertfordshire, or Hatfield Polytechnic as it then was. Our facilities director, Bridget Floyd, also coincidentally has a degree in environmental science, and we've both worked together quite closely, her as facilities manager and me as IT services, to develop a number of green initiatives.
What was the start of the inspiration for the energy project that you undertook?
Well, we had a new build in 2007, so we had the opportunity to rip out and start again with our IT infrastructure. So we put in a new network, new server room. We were voice over IP, IP telephony throughout, and then IP CCTV throughout. And at the time of the new build, we also decided to investigate server virtualisation. We did this at the time largely on the back of the business benefits it brought from being able to provision servers quickly, disaster recovery, business continuity, that sort of thing. But we very quickly realised there were a number of environmental benefits that went with it. We were able to reduce our server room infrastructure from, at the time, 54 servers down to 5, and there was a huge reduction in kilowatt hours used from getting rid of all these physical servers, as well as a reduction in cooling too. And that was just on money saved on the electricity bill. There was also a lot of money saved on server refresh every year. So we continued down the server virtualisation route and virtualised all the servers that we could. Some servers can't be virtualised, like CCTV servers, Oracle database servers, but the majority of servers can be virtualised, and you recognise a lot of business benefits but huge environmental savings. After the server virtualisation was so successful, we got the green bug, if you like, so we started looking what can we do on the desktop, what can we do with printing, where else in the college can we save money. So Bridget and the facilities team started replacing standard light bulbs with LED light bulbs, ripping out fluorescent lights and replacing them with low energy ones, starting small in the lifts but then going and replacing all the light bulbs throughout the college. As an IT team, we investigated greener printing. We measured the energy consumption of our HP printers and ended up changing to Samsung printers because they had a lower energy draw on standby as well as when they were printing, as well as reduced toner costs. And every time we buy new PCs, one of the first things we do, as well as evaluating the spec and performance, is plug them into an energy monitor and evaluate the energy use of the PCs, both in standby, in normal usage, and then in like high power usage, so say for video editing. And we'll factor that in when we come to choose a branded PC. We then looked at the usage of the PCs during the working day, and we'd find that PCs will get left on in staff rooms and classrooms between lessons or at the end of lessons or at the end of the evening. So we bought a commercial product called PowerSave. Now that worked very well and it gave us a lot of useful reports, how much energy it saved. We configured it to shut machines down after half an hour, but we quickly got the odd complaint. So if, for example, a classroom was all sat watching a video, then they might not be using the machines, and the last thing they want is the machines to shut down on them. So we quite quickly decided we'd develop our own system, and it was a very simple system. It was a shut down and power off script, so we removed all the options on the machine so that the only option that users had was to shut down and power off. No logouts, no restart. If the user wants to restart the machine, they have to shut it down and it powers off, and then they have to press the power button to start it up again. And that meant overnight, when we deployed it in the user's login scripts, it meant overnight that not a single machine in the college was left on. Now, obviously there are exceptions. You might have library terminals or counter machines where you're serving people that you don't want them turned off, and obviously servers aren't affected. But the 99% of users' PCs now are never ever left on. The only option you have is to shut down and power off.
You've told us a little bit about the sort of energy savings that you made actually in classrooms with shutting down PCs. I understand you've also involved some solar panels and energy saving from external sources and green energy as well.
Yes, our facilities team were the first college in the country to install a device called a mains optimizer. It drops the mains voltage down from the standard 230, 240 down to 220 volts, which, as you can imagine, on a college of any size, and the electricity bill that a typical college faces can make a huge difference to the energy consumption. The cost to implement that was around about £70,000, but the payback time is 4 years, and from that point on, it's you're making money from it. Then you've saved after year 4 onwards. But it has a huge environmental benefit because it reduces the energy consumption of all attached devices to it. Now, it doesn't affect things like servers or any other delicate equipment, because they're all designed to operate on the European standard of 220 volts anyway, so they're not affected. Our server in UPS doesn't notice or mind that the voltage to the college has been dropped to 220, and all of the devices have a reduced energy consumption as a result. Also, we have a town centre campus called Museum Street. Now, Museum Street campus is quite an old building. It's a listed building, I think. We replaced the water heating with solar water heating, so that building is 100% solar water heated now, and we were able in 1 year to reduce the electricity bill on that building by 23%. Now, many of you will know that electricity bills are scheduled to go up by 20% or so next year, so you never manage to catch up, and you never really manage to save money. But if you don't do this sort of work, then your electricity bill will be unbelievably expensive. So we've saved 23% in 1 year just on one building. Now, over at the main site, we fitted a number of solar water heating panels, as well as the solar photovoltaic panels. Now, these are primarily used as a teaching aid at this campus. We're running courses in solar installation from September, and the students will work on these and will learn how to install them on people's homes and how to attach them to the national grid, because you need special certification to be able to do that. But it's an area that is financially viable now. Home users can get grants to install solar power on the roofs of their house, and the payback time actually is financially worthwhile now.
Can you give us some of the examples of the cost savings that you've made, please, Nick?
Yeah, server virtualisation. We sat down and we worked out, both from manufacturers' figures and from our own measurements, the energy consumption, the realistic energy consumption of each of the physical servers that we had. We were using HP DL360s at the time. We also worked out the energy consumption of a larger, more powerful server running VMware ESX, and we worked out how many physical servers we could migrate over to virtual servers, and we worked out that the virtualisation project would cost us around £65,000 for the hardware and the licenses, but that we'd get payback just on energy alone in a 5-year period. Now, that includes cooling, because obviously if you've got a server room packed full of servers, in our case we've got 2 air conditioning units running 24 hours a day. Well, if you're not even halving the number of servers, but you're dropping them from 50 down to 5 or 6 as it now is, we're able to run on just 1 air conditioning unit. The other one's left powered off but it's still in place just in case we lose an aircon unit. So we were able to demonstrate to our finance departments that if we were allowed to spend this money, that we will get paid back in 5 years' time. But that excludes the money that you would normally spend on server refresh anyway. We would typically replace servers every 3 years, maybe the lower power servers every 4 years. So once you factor in the server refresh as well, then your payback time becomes around 2.5 years for server virtualisation. And it really is a no-brainer not to do it. Not only do you benefit the environment from your reduced energy consumption and good publicity and all sorts of that generates with it, but you get huge business benefits from being able to deploy a new server in seconds, being able to clone servers, being able to back up and restore servers in minutes instead of hours. There's just absolutely no reason not to virtualise. So we're looking at the same thing on the desktop now.
Have you got any other additional benefits from the ones you envisaged at the outset of the project?
Well, like I said, with server virtualisation, if we're honest, we looked at that originally from the business benefits, being able to recover a failed server in minutes rather than hours, being able to provision new servers in seconds rather than sitting there loading disks into a physical box. But having an environmental background anyway, then the environmental benefits became clear before we'd set off on the project. Just while we were costing it out, we could see the environmental benefits as well as the business benefits. So, being bitten by the environmental bug and realising that it's actually now cost effective to do these sorts of projects, we looked at desktop virtualisation now and desktop power saving. Now, the desktop virtualisation, it's a harder project to do, I'd say, but that brings a whole host of benefits to users. I mean, imagine say an AutoCAD student or a media student at college who can't afford to buy the software, but then imagine that same student being able to log in at home just over a web browser and fire up a virtual machine and fire up a college licensed copy of AutoCAD that's not currently in use, and being able to complete the projects or complete their homework or assign tasks rather than actually have to be on site. It also makes room utilisation a lot easier, because we will be able to, when we're fully desktop virtualised, we'll be able to provision any piece of software in any room at a moment's notice. We'll be able to do professional training for a third-party organisation that might want a particular piece of software. We'll be able to design a single virtual machine and provision that to a whole entire IT suite, or indeed to do off-site training for them as well, but all using our college licensed software, because it's a lot of it's concurrent license, and out of hours you might have 30 or 40 AutoCAD licenses sat there not being used. Well, your students can just use them from home without actually buying the software. So there's a typical college desktop running Windows XP, running on my iPad using the free VMware desktop client, and you can see it's difficult to work it upside down obviously, but you can see that it's fully responsive. I can browse, if I can find the icon, I can browse Internet Explorer, except I can't double click on it. There we go. So we've got any application. Now that could easily be running AutoCAD or running a multimedia application, and if you can do it on an iPad, which is just basically a web-based tablet, then you can do it on any home PC that a student might have. And in the case of the iPad, you get a full on-screen keyboard as well when you wish to type in the address bar.